Gravity. We all need it. We all love it. It keeps us on the ground, it keeps us orbiting the sun, and we learn about it in physics class. There is even gravity in video games, like Minecraft. Don't fall from too high up or else... Okay, so gravity's pretty cool, but how does it work? Well, you see, mass curves space-time or something, and well, that's a bit beyond my expertise. For now, we're going to talk about gravity as a simple force equal to gm1m2 over r squared. When standing on a planet, though, it can make more sense to describe gravity as accelerating objects downward. On Earth, this acceleration is about 9.81 meters per second squared towards the ground. You can then use this equation to relate things like time, velocity, height, and acceleration. So, if I know my initial height, initial velocity, and the time it took to hit the ground, I could use that information to calculate the acceleration of gravity. That's what I'm gonna do today, but in Minecraft. Okay, so this isn't the most original idea, and I bet many people have done this before, but I want to try it just for fun, see what happens. Alright, so I should state a few assumptions first, however. First, we're assuming no air resistance, because that's complicated and I don't want to deal with it. So I'm going to pretend like air resistance isn't real. Anyway, enough with boring stuff, let's jump off some blocks and see how long it takes for me to fall. Okay, so I recorded myself falling 3 times from 3 to 8 block high falls. I then used F3 to determine the time I started falling and the time I hit the ground, and then calculated my total fall time. Also, one Minecraft block is 1 meter tall, which will be important for the math. So here are the data, but even better, here's a graph showing the data. As you can see, we have the fall height on the y-axis and fall time on the x-axis. What can I do with this information? I'll come back to that in a moment, but first let's do a little bit of algebra. Okay, so remember this equation, we're going to use it. Now, for my trials, what do we know? We know the initial height I fell from and the time it took to fall in each trial. But we also know that initial velocity because I didn't jump off the block or anything, I just fell off. This means my initial velocity in the y direction was 0, meaning we can rearrange the equation to this form. Acceleration equals 2 times the height divided by time squared. So, since the acceleration of gravity is twice the fall height divided by time squared, let's plot height versus time squared instead. This will do 2 things. First, it linearizes our data, which makes it easier to work with. The other thing is, it displays a relationship between the numerator and the denominator of our acceleration function. Specifically, the acceleration function is equal to twice the y variable divided by the x variable. This means that the slope of the line of best fit for the data we just plotted, multiplied by 2, would be our best guess for the acceleration of gravity based on our data. Next, we just plug the data into our computer and we get a slope of 13.1002. Here's the full analysis if you want to see all of the numbers. Okay, so the acceleration due to gravity is about 2 times 13.1002 meters per second squared, or about 26.2004 meters per second squared. Although I only really know that to about 2 sig figs, so I'd say about 26 meters per second squared. Now, this is a pretty big value for the acceleration of gravity. This is more than the acceleration of gravity on Jupiter. But let's go one step further. How big would the planet of Minecraft be? We're going to assume that planet Minecraft is a sphere and has a density equal to that of Earth, which is 5,515 kilograms per meter cubed, according to Wikipedia. Force is equal to mass times acceleration, and the force of gravity is equal to gm1m2 divided by r squared. So, if we let m1 be the mass of the planet and m2 be the mass of an object accelerating toward the planet, we can divide by m2 to get the acceleration of gravity on the planet. This means that 26.2 meters per second squared is equal to gm1 over r squared, where m1 is the mass of the planet, and g is just a constant that we can plug in. Because density is mass divided by volume, and the volume of a sphere is 4/3 pi r cubed, we can say that 5,515 kilograms per meter cubed is equal to the mass of the planet divided by 4/3 pi r cubed. We can then use these equations to solve for r and get a value of about 1.7 times 10 to the 7 meters. For comparison, the radius of the Earth is 6.3781 times 10 to the 6th meters, so planet Minecraft would have a radius about 2.7 times bigger than the radius of the Earth. That's pretty big. Well, that's all the math I have for today. I thought it worked out pretty well. I didn't collect a lot of data, so my estimate probably isn't super accurate. I also only recorded at 30 frames per second, which limited how exact my measurement for the fall times could be. But yeah, thanks for watching this video. I hope you liked it. Goodbye.